Recording? Yeah. We're going over the Sig Figs FIP quiz. So in that first section, you had to identify how many significant figures there were in each. In this number, they are all significant. Every single one of them. So this one is significant. Why? Between two non-zeros. This one is significant. Why? Between two non-zeros. So they're both significant on the same rule. So that has 7 sig figs. Okay, looking at the second one. There are 4 sig figs in that. 2 of those zeros are significant, 2 are not. Which 2 are significant? These are significant because they're between 2 non-zeros. These are not significant. They're at the end of a number, but in front of the decimal, they are not significant. So that has 4 sig figs. How many sig figs in this one? This one I think most people got right. 3. These 2, well, none of those are significant. These are in front of the number, behind the decimal. They're placeholder zeros, and only these are significant. Okay, here we've got a mix of things. This has 3 sig figs. This one has 4 sig figs. 2 of those zeros are significant. Which ones? The one that's in between, and which other one? The one at the end is significant. Okay? It's at the end, behind the decimal, it's significant. This one is not significant, that one's not significant, so that's 4 sig figs. How many sig figs in that last one? 1! These are not significant zeros, so that has 1 sig fig. I think most people are fairly comfortable with just straight out identifying how many sig figs there are. I didn't have as many mistakes in that section. But let's look at the rounding. So we have the number 6124.0215. We want to round it to 3 significant figures. So I'm going to underline that, and that then rounds to 6,120. Okay? Most people did pretty well with that. I have the number 9869.50, and I want to round to 2 significant figures. I'm going to round based on that number, so I end up with 9,900. This is the one that gave most people problems. 4,612.9903. And I want to round that to 5 significant figures. So I'm going to go to here. What happens here? We don't know. Okay. The presence of this is going to make this number round up. You round up a 9. Goes up to the next 10. So because this is a 9 rounding up, that bumps this one up. And the correct answer is 4,613.0. Okay, that's a tricky one. I put that on there for a reason. Those are tricky cases. Okay, and finally we have 94,905.0230. We're going to round that to 1 sig fig. We can only round on the basis of the number that's directly behind it. And I threw this in here intentionally because some of you would look at that and go, oh, it goes up. It doesn't go up. It does not go up. So that becomes 90,000. Okay? And this is where I'm seeing a lot of issues still. Things you can't do. You can't put a decimal after this and substitute in zeros. That makes those significant. Then you're violating the whole point of the rounding. So we'll work more on that as we go. Okay, record the correct value for each of the problems below. So here we had a mixture of things. You had mathematical operations that you had to perform, some with scientific notation, but you also had to record the correct number of sig figs in the answer. So for number 10, that first problem, the raw answer that you should have gotten was negative 26.2599. Now, the limiting, this is addition and subtraction. So the rule for addition and subtraction is the number of places behind the decimal. One of the numbers in that problem was a 3.9, which means we can have one place behind the decimal. We're going to round to there. So the correctly recorded answer is negative 26.3. Okay. For the next one, it's multiplication and division. Your raw answer, let's see, so I'll put down raw and correct recording. So your raw answer was 1,507.6039. You could have 4 sig figs, so that makes your correct answer 1508. All right, for number 12, your correct raw answer was 3.34 times 10 to the 6th, but we can only have 1 behind the decimal. So our correct recorded answer was 3.3 times 10 to the 6th. For number 13, the correct raw answer was 2.4058 times 10 to the 12th. You can only have 1 behind the decimal, so 2.4 times 10 to the 12th is the correct recorded answer for that. Do you feel clearer on those, having seen the answers? Okay. We'll go through all this, and then I'll work with people individually if they need some help. You can do what you need to do. I'm going to keep recording. Okay, to convert each of the following, we have 1.5 times 10 to the 6th centimeters, meters. We want to convert this into kilometers, kilometers. And again, this is mostly a matter of remembering your prefixes. So here we have 1.5 times 10 to the 6th plus negative 2 minus 3. That's 1.5 times 10 to the 1st kilometers. We have 0.00675 megagrams. We are converting into micrograms. Megagrams, grams, grams, micrograms. 1 times 10 to the 6th, 1 times 10 to the negative 6th. I'm going to convert this to make my life easy. 1, 2, 3. 6.75 times 10 to the negative 3rd. 6.75 times 10 to the negative 3rd plus 6 minus negative 6. Negative 6, we end up with 6.75 times 10 to the 9th micrograms. Okay, let's get rid of that. We have our last one, 8.5 times 10 to the 14th nanoliters. 8.5 10 to the 14th. We put down nanoliters, liters. We want to go into milliliters. So we're going to do liters, milliliters, boom, boom. 1 times 10 to the negative 9th. 1 times 10 to the negative 3rd. So we now have 8.5 times 10 to the 14 minus negative, plus negative 9 minus negative 3. And we end up with 8.5 times 10 to the 8th milliliters. Okay, the answer key will be online, so you can look at that, and if you need additional help, you need to see me.